Hi everyone, my name is Zhongyuan, and in this video I will talk about the Big Bang theory, which I believe everyone may have heard of before. So what is the Big Bang? Is it an explosion like a bomb blasting out into the shouting air? No, it's not. It is the idea that the universe began at a single point, then expanded and stretched to grow as large as it is right now, and it could still be stretching. In other words, the Big Bang was an expansion of space itself. Astronomers noted that the light from the stars in nebula was shifted to the longer wavelengths of the spectrum, indicating that the nebula are moving away from us. When Hubble figured out the distances, he was able to note that the larger the redshift, the faster the galaxy was moving away from us. The farther away it was, the Doppler effect causes light from objects receding from us to be shifted to the longer wavelengths. Light from the approaching objects is shifted to the shorter wavelengths. In 1929, Edwin Hubble announced that his observations of galaxies outside the Milky Way showed that they were systematically moving away from us with a speed that was proportional to that distance from us. The more distant the galaxy, the faster it was receding from us. Imagine that someone is making a raisin bread and you are standing on a raisin and you will see other raisins are moving away from you. That's how they come up with the idea that the entire universe is expanding. Here is the video I got from NASA. It demonstrates the Big Bang, the beginning of the universe. After the Big Bang, space and time were created. So if you are wondering what happened before the Big Bang, then it would be like you are standing exactly on the North Pole and you are asking what is actually to the north. I mean, it's like, what is the north to the North Pole? The question itself doesn't make any sense. Here is the timeline of the universe. So you should know, before it was 10 to the negative 43 seconds, all of the four fundamental forces of nature were unified into a single force: strong force that hold the nucleus of the atom together, electromagnetic force, weak force that governs some radioactive decays, and gravity. At 10 to the negative 43 seconds after the Big Bang, gravity separated. At 10 to the negative 35 seconds, the strong force separated from the combined electromagnetic force and the weak force. At this time, the universe went through inflation and it was increasing in size. Before 10 microseconds, the universe consisted of a sea of quarks. At 10 microseconds, the quark condensed into elementary particles, protons and neutrons, and their antiparticles. The temperature of the universe now was 10 to the 27 Kelvin. It was too hot for protons and neutrons to form. At 10 microseconds, however, quarks can combine to form protons, neutrons, and their antiparticles. Because the universe now began to cool down by expansion, and photons lack energy to break up new particles. Before the universe was 3 minutes old, matter existed in the form of free protons, neutrons, and free electrons. If a neutron and a proton came together to form a single nucleus, the next collision could be so violent that it could be torn apart. At 3 minutes, however, the temperature had fallen to the point that the free protons and neutrons can start to build nuclei. The universe is expanding, carrying particles away from each other and making interactions less frequent. Various forms of hydrogen, helium, and lithium appear. Heavier elements and everything else is created later in supernova and stellar evolution. As the universe cooled, the neutrons either decayed into protons and electrons or combined with protons to make deuterium, an isotope of hydrogen. During the first 3 minutes of the universe, most of the deuterium combined to make helium. Lithium were also produced at this time. This process of light element formation in the early universe is called Big Bang nucleosynthesis. The abundance of light elements in the universe nowadays is the strongest evidence for the Big Bang theory. At a few 100,000 years, these nuclei began to capture electrons and became atoms. The formation of atoms was a particularly important event because it released the radiation that became the cosmic microwave background and marked the point at which ordinary matter could start to collapse into galaxies. Hydrogen helium atoms under gravity influence began to clump together to form galaxies and stars. Last but not least, the cosmic microwave background radiation is the strongest evidence for the Big Bang theory. So if the Big Bang theory is correct, so the universe would have a hot beginning and it has been cooling ever since. The cosmic microwave background radiation is isotropic and uniform in all directions. The different parts of the universe from which the radiation comes are all at the same temperature to the same level of accuracy, implying that 379,000 years after the Big Bang, all matter in the universe was uniformly distributed. However, matter in the present universe is not uniformly distributed. In 1992, measurements made by NASA Cosmic Background Exposure Satellite revealed that the background radiation is, in fact, not perfectly uniform. This uniformity is one compelling reason to interpret the radiation as remnant heat from the Big Bang. Most cosmologists believe that the galaxies that we observe today grew from the gravitational pull of small fluctuations in the nearly uniform density of the early universe. These fluctuations leave an imprint in the cosmic microwave background radiation in the form of the temperature fluctuations from point to point across the sky.